Okay, it's a little daunting being the first presentation in the entire conference after that, after the great keynote, but let's see if we can keep it interesting. I'm going to go through a topic that is sometimes one of controversy and contention. Hopefully, we'll cover some things that you guys can relate to. Maybe you've dealt with some of these issues, and you'll be able to at least relate. Some of this will resonate with you. My name is Hooman. I'm the VP Technology at Fastly. Most of my work is around performance, so the things that I'm talking about here are things that I deal with on a daily basis. I also see a lot of our customers struggle with this stuff, and I actually did a lot of this stuff when I was out of the CDN industry, when I was evaluating different CDNs before I got into the CDN industry. So let's start with why this actually matters. When we think about CDNs, performance is one of the main reasons that we select a CDN. And at the surface, it kind of seems like easy to measure, but it isn't. And most often, performance measurements happen in the evaluation phase. So it's really important because if you're in a place in your business that you're evaluating different CDNs, you're going to have a performance measurement challenge. And this is where this stuff becomes really important. It is very nuanced, and we run the risk of essentially going into metric overload. Well, when I start talking about metrics, you kind of see why that's a thing. There's a lot of mistakes we make. We get lost in the data. So when the metric overload happens, we get lost in it. We lose many, many precious cycles trying to figure out what the right thing to look at is and what the wrong thing is to look at. We end up focusing on one thing. Because we really like lists. We really like ranking things from 1st to 10th and choosing the one that's 1 over the one that's 2 because it's an easy way to make a decision. And this is the way we shy away from some of the complications and nuances that are involved here. We may forget about our applications and some of the bigger picture. I'm going to try to focus you on that. And we let vendors influence us. I realize the irony of this as I am a vendor standing in front of you and telling you what to do. That is not my intention here. My goal is not to influence you. My goal is just to share with you some of my experiences. And hopefully some of this stuff will resonate with you, and this can be somewhat educational. I want to share with you what the measurement landscape looks like. I'm going to share with you with some metrics to look at, and hopefully help you avoid a bunch of the pitfalls. Let's do some background first. Just for reference, humor me, how many people know what a CDN is? Great. And how many of you have ever dealt with measuring performance for a CDN? Great. Okay, so some of this stuff will be easy, some of this stuff will resonate with you, and some of this stuff may be really boring, but we got to go through it. This is what a CDN looks like. If this were at all legible with the red background, you'd see that these are nodes. This is Fastly's footprint, but every other CDN has something like this. You have a set of distributed cache nodes all over the world, and as such, these cache nodes deliver content and applications for your users. At the core, CDNs are delivery platforms. As delivery platforms, they offer lots of services, caching just being one of them. They just happen to be built on proxy caches. But as a delivery platform, they bring you a lot of services. Those services include things like security, global server load balancing, TLS offload, lots of other things. And we're not going to talk about any of those things. Some CDNs will also offer you page-level optimization, things known as FEO, front-end optimization, WPO, web performance optimization. We're not going to talk about any of those things either, not because they're not important, but because they're layered features that actually have nothing to do with the CDN itself. So we're going to focus more on the delivery side of the CDN, and when it's the main responsibility of the CDN, which is to deliver objects to your users. That's the thing we're going to focus on. When it comes to delivery, CDNs deliver two types of objects. The first type is static or cached objects. And these objects are delivered, hopefully, from a cache machine or set of machines that are close to the user that's fetching them. And when you test these types of objects, what you're actually testing is things like routing algorithm. Did the CDN get you to the right POP? The storage models for the CDN. Did the CDN serve the content to you as quickly as possible? The efficiency of that delivery. Those are the things that you're testing when you test this type of object. There's another type of object, and that is dynamic or uncached objects. Again, because the CDN is a delivery platform, it may be responsible for delivering things from the origin through the CDN to your users. These types of objects have a completely different profile because they're not coming from the edge, they're coming from the origin, maybe through the CDN sort of network as an overlay. When you test these sorts of objects, you're kind of looking at different things. You're going to be testing the efficiency of long-haul routing. You're going to be testing the efficiency of protocol algorithms. You're going to be testing the efficiency of connection management to the origin and general management of the origin sort of back-end side when it comes to CDN. So these are a separate set of things that you're going to be testing, and it's always important to understand what object and what type of object, what profile of object you're going to be testing when you do these measurement tests. And when we talk about later on, when we get into the weeds a little bit and talk about what metrics to look at and what objects to test, these are the things, these are the lenses I'd like to make sure that we look through. We're going to focus on three main areas. We're going to focus on how we measure things, so we're going to talk about measurement techniques. We're going to talk about metrics, so the sort of core metrics that you should look at when you do these sorts of things. And we're going to talk about what to measure, so the objects or object types, so a little bit more about what I just talked about. We're going to talk about the objects that we measure. And I'm going to talk along the way a lot about gotchas, common mistakes, things, bad routes that I've seen a lot of customers and myself actually in the past take when measuring CDN performance. And hopefully at the end of this will be somewhat educational. So let's start with measurement techniques, which is how we measure CDN performance, or kind of performance in general, but I'm going to focus us towards CDNs. Now, when it comes to measurement techniques, you guys probably already know that there's two categories of testing platforms or measurement platforms. One is made up of pretend users, and one is made up of real users. The pretend user category is what's commonly known as synthetic testing. You've probably heard this term before. Synthetic tests are not actual users, but they're machines that pretend to be actual users. And the metrics they report are what is expected for your users to experience. Real users are actual users, and these are the sorts of measurements, and these are the sorts of products that actually do testing inside the browser at the actual user. And this is a good thing because it's the real users, it's actual users, but it has its own caveats. Let's talk about synthetic testing first. Now, synthetic testing vendors usually have a large network of testing nodes, sort of globally distributed. If you've ever used one of these guys, you'll know that when you pick a node to test, it'll be the location of the node and probably the carrier that it's connected to or the carrier that it's sitting on. So it'll be like Boston and AT&T or something like this. They're highly scalable. They're built to do this. They can do lots of tests at the same time. You can do very, very frequent measurements. There's lots of vendors in this category. You probably have heard of vendors like Catchpoint, Gomez, which is now called Dynatrace, Keynote, Pingdom. There was a vendor called Watchmouse that got, I think, acquired by CI. There's a bunch of vendors in this area, and they make huge money. And these are legitimate businesses because this is something that's important. But they were not built originally to test performance. They were actually built originally, most of them were built originally to test availability of applications. They sort of morphed into performance solutions. Now, they're built to do lots of things. They're doing full application performance and measurement testing, and as such, they have lots of different monitors, ways of doing testing. Things like DNS, pings, streaming tests, trace routes, which are really important for network reachability. They have lots of different ways of testing. For HTTP, which is the area that we're going to focus on, they generally have three types of tests. One is fetching an object, so just fetch an object, kind of like curl, if you were to run it in your machine. They do a browser test. They'll launch a browser and actually fetch a page through a browser and sort of give you some browser metrics. These are pretend users, but it's a real browser. Or they'll do transactions or flows, which is like going from page 1 to page 2 to page 3. So populating a shopping cart and going through a checkout process, booking a hotel, these sorts of things from point A to point B. When you set these things up, you set up a test, you pick some locations, you pick a frequency, you let it run, and after a while you go back and look at how your performance looked. There'll be aggregated reports that tell you what's going on. Now, synthetic testing vendors generally have two types of nodes. The most common one, and how sort of they started, was this node known as the backbone node. And this is a test machine that's sitting somewhere in a data center on a backbone somewhere connected to a probably level 1 carrier, and doing testing as a node on a sort of at the elbow of the internet. The problem is these are terrible indicators of performance because there's no actual last mile real user latency, which you experience in your home connection. Backbone nodes do not experience this whatsoever. And they kind of have access to infinite bandwidth. So it's not like there is no 5 meg, 10 meg, 15 meg cap that the backbone provider has provided that's put on these backbone nodes. So they're terrible indicators of performance because nobody surfs the internet like this. Now, I realize that maybe most of you surf the internet like this. I've certainly surfed the internet like this before, but my mother doesn't surf the internet like this. She has cool Converse like that, but she doesn't surf the internet like this. And this is why they're terrible indicators of performance. And CDN vendors for a long time did all of us a disservice by giving us performance metrics from backbone nodes. And the test machine was often in the same cage or in the same data center as the cache machine it was testing, which is completely unrealistic. For a long time, I still see this from a lot of vendors. I still see customers come to me with these sorts of numbers that are actually meaningless for real performance. So I think backbone nodes have great advantages. I think they can help you figure out availability of applications, maybe know how slow the back-end side of your application is, test scale, load testing. They have global reach. Those are great things. When it comes to performance, they're not necessarily the best indicators of what your users will be experiencing. So they have their place, but I generally dissuade people from using backbone nodes when it comes to performance testing. And vendors sort of figure this out over the years. So what ended up happening over the last few years is the emergence of these things called last mile nodes, which are intended to emulate actual users. The idea is still that these are fake users, but they're experiencing real world conditions. So for example, what the vendor may do is they may send a test node to your home, and you put it in a corner. They may pay you to do this, and then they'll run tests on it. That node is experiencing real last mile latency conditions and real last mile bandwidth restrictions. And that is a much better indication of performance. It's still a fake user, but it's a much better indication of what your users will be experiencing. But it may not always be reliable either. Let me tell you a quick little story. There was a node in Miami that I was using with one of these vendors, and the node went down. It's like a computer in a home, right? So shit happens. And the guy was on vacation for 2 weeks. We couldn't reboot it. So for 2 weeks, I had 0 eyes, for example, in Miami because I couldn't test from there. Those things happen. So when you use last mile nodes from these vendors, just sort of be aware of those types of things because there are machines sitting in homes and probably managed by people. So just be careful about that. They're also not as dense in deployment. Now, this is the deployment map for CatchPoint. I'm sure every other vendor has something like this. I just happened to find the one from CatchPoint easily, so I'm using that one. You'll see there's a lot more backbone nodes than there are last mile nodes. That's one of the disadvantages of using last mile nodes. They're much better for performance metrics, but they're not as dense. Over time, I think this will change. Obviously, it's harder to deploy machines in people's homes, for example. And over time, this will change. But for now, we kind of have to live with it. I still think it's pretty cool. It's a much better indicator to use last mile tests for performance, to use last mile tests than to use backbone tests. So let's round up synthetic testing. The pros are that there is good geographic distribution. There's lots of options for testing. It's actually really good for on-the-spot checking. So for us, when we have a problem, it's really easy to jump on one of these nodes and do an on-the-spot check. And last-mile nodes can end up being really good proxies for what your users are experiencing. It's not as good as actual users, but they're pretty decent proxies. The cons are that they're not real users. Obviously, these are simulators. These are machines that are pretending to be users. And the biggest con of all, the biggest downside of this is that backbone nodes can really be misleading when it comes to performance. And they were for years, and we're still sort of digging ourselves out of this perception that backbone test numbers are actually meaningful. They're kind of not. So if one sort of category of testing is synthetic testing, which is pretend users, the other category is real users, what we generally call RUM, real user measurements. Now, RUM is kind of the platform or the technique where you use JavaScript in a browser to collect a bunch of metrics in that browser from actual users. And lots of things can be collected because browsers now give us lots of APIs that report performance metrics, and this is a good thing. Over the years, RUM-type solutions have gathered a lot of momentum, and browsers are now providing us these metrics through APIs. Now, RUM is typically used for page measurements. So RUM vendors, which I'll talk about in a second, use RUM to tell you how your application is performing. But these techniques can also be used for testing performance. And I'll separate what those in a bit, why those two are different things. Now, there's two ways to use RUM techniques. One is to use test assets. So you write a JavaScript, you put it in a page, and after the page loads, you initiate some tests sort of under the covers to test objects. This is kind of, Steve Souders called this synthetic RUM. So you're using RUM techniques, but you're actually testing a test object, which isn't the real assets in your page. There's a bunch of vendors in this. You may have heard about some of these vendors. Sodexis is probably the big one. TurboBytes, Cloud Harmony, they all deploy these types of metrics. And what's interesting about they deploy these types of measurements. What's interesting about these vendors is this data isn't actually their core business. They're not selling the data, and they're not measurement companies. They actually have some other business that they're using the data to drive the primary objectives of that business. For example, Sodexis is a CDN load balancing company and cloud load balancing company. They just use a lot of data that they collect through these techniques to decide how to load balance, and they expose that data to the world. You can actually go to their site and look at some free reports, which I'll show you later. And you can build this stuff yourself. So I've seen customers that actually built their own JavaScript and deployed in their own pages and do this sort of technique to collect a bunch of performance metrics from test assets. Or you can use real assets. You can actually use the real assets on the page that you've downloaded from the CDN and use measurements associated with them through something called resource timing, which I'm going to delve into in a little bit when I talk about metrics. And again, those are APIs that the browser exposes to you, and you can do that. It's just a lot of data, and it's a little bit difficult to collect it, but it's actually available. So I've also seen some users and some customers out there start using resource timing. RUM vendors are aplenty. You may have heard of vendors like Sosta or New Relic. Most synthetic companies have also started going into RUM, so all the vendors that I talked about in the synthetic slides also sort of apply here. You can use an open source library called Boomerang. There may be others, that's just the one I know. Or, believe it or not, Google Analytics does this. So Google Analytics has RUM sort of built in, page level RUM, and you can do your own metrics and sort of feed into it. There's a set of custom metrics that are performance custom metrics. You can do your own measurements and kind of use GA as a data collection platform, which is kind of cool, actually. What's interesting about RUM is if you use RUM, these are real users that are going through a lot of real-world situations, and that means there's a lot of variance. So to have the meaning, so for this data to be meaningful, you kind of need a lot of data. You got to collect and collect and collect. So that's kind of a challenge, but when you have that amount of data, this data could be extremely valuable, and you can do lots of cool things with it. Because of this variance, lots of vendors across the board aren't using averages anymore because averages are really susceptible to bad variance. So you'll see lots of medians, lots of percentiles. You see measurements like that being the key core metrics that a lot of vendors report. So the pros of real user measurements are that they're real users. They're happening in real browsers. They're subjected to real world conditions. That's awesome. If you use your own content or your own assets, it could really be representative of what your users are experiencing. And if you have enough data, you can do amazing analysis, very granular. How are people in this network experiencing performance? How are people on this ASN through this backbone? That's a lot of valuable information that you can use. The cons are that we need a lot of data. If you decide to do this yourself, building a data infrastructure is actually a lot harder than it sounds. So that's the ways we measure. So synthetic testing, when you have pretend users, and real user testing, where you have actual users in actual browsers, whether you use test assets or real assets. So that's how we test. Now, let's say we use one of those techniques, and now we want to look at what metrics to look at. So now I'm going to talk about those metrics and what the core metrics are that you should look at. To do this, we need a little bit of background. And that is a review, hopefully, for all of you, of how a client talks to a server in the world of the web. Now, as you know, CDNs are made up of generally caches that pretend to be servers. So everything that I'm going to talk about here applies to a client talking to a web server. It also applies to a client talking to a web cache on a CDN. Now, the network distance between these two machines is we generally refer to it as 1 RTT, a round trip time, how long it takes for a packet to go from me to the CDN node and back. That's 1 RTT. Now, when a browser talks to a server and fetches an object, first, it starts by doing some DNS lookup to a DNS infrastructure that is not necessarily the CDN nodes itself. And it does that. It figures out what the IP of the node is. The CDN, through some algorithm, tells you what the node is that you should be speaking to. That's a thing that you should measure as well. We'll talk about that in a bit. And then there's probably a TCP connection that needs to open. Then there may be a TLS connection if it's a secure connection. Then there's an HTTP request, and then the content comes down. So all these things need to happen in order for your browser or your consumer, your client, to have an object. So if you look at the lifetime of an object, this is kind of what it looks like, and these are the components that go into the end-to-end performance of an object being fetched from a server. If you've ever looked at waterfall charts, and analyze page performance, you'll see that every asset has something that looks like this. Now, every one of these things is dependent on something else, on a particular set of conditions. So the DNS, for example, is dependent on how far you are from your DNS resolver and how that DNS resolver, how many iterations it needs to go through to fetch the answer for you, how well caching is being done, how many layers of lookups there are. All these are things that go into how long that component takes. After you get the IP address of your server, you need to set up a TCP connection. That is generally dependent on round trip time to the server. A TCP connection through a handshake usually takes 1 RTT. So this is a function of how close the server is that you've connected to, and how that's the routing algorithm of the CDN. Then you may need to negotiate a TLS connection. That used to be a 2 round trip problem, or a 2 round trip process. With the advent of TLS false start, that is being reduced to a single round trip. False start is something that's supported by most modern browsers and most modern servers, but it's not everywhere. So as you're doing some of this testing, make sure that your CDN or the CDNs that you're evaluating support false start, and hopefully your browsers, most of your users' browsers also support it. It's something that's sort of negotiated during TLS setup. Then you have an HTTP request that goes out. The core component we'll look at here is time to first byte. Time to first byte is essentially a function of how long it takes for your request to hit the server, and then after hitting the server, how long it takes to hit the object. So the object may be somewhere deep in the server or in the infrastructure, and then how long it takes to get back. So that entire process is time to first byte, which is probably the most important metric when it comes to CDN performance, because it tests lots of things. The lower bound of this metric is round trip time, but that's not necessarily, like the best case scenario is if TTFB equals TCP round or RTT or TCP time essentially. But that's not always the case, and I'm going to get into this in much more detail in a little bit. And finally, you have download time, which is time to last byte minus time to first byte. I did that backwards. Time to TTLB minus TTFB. So time to last byte minus time to first byte, which is how long it takes from the first byte arriving at your browser until the last byte. And this is download time. This is a big deal if you're fetching objects that are not necessarily small. The larger the object, the bigger component this particular metric is. And this metric is a function of bandwidth. It's a function of TCP algorithms, congestion avoidance algorithms, and a lot of people forget that this is also dependent on RTT a little bit. And I'll talk about why that is when I'll give you a little TCP thing, and I'll talk about that. Now, not every request that your application experiences is exposed to all of these metrics, because it's possible that you're using a persistent connection, for example. You've already negotiated TCP, you've already done your TLS handshake, and all you get is the HTTP part. Or you have DNS caching that happens, and you only look up DNS once per domain. You set up TLS only once per connection. You do experience time to first byte and HTTP fetches for things that are not in your browser cache with every single request. And this is probably why I talk about TTFB, especially for small objects, being probably the most important metric that you measure. And whatever tool you use, whether you're using a synthetic vendor, you're using RUM metrics, whatever tool you use will report these metrics to you, all of them, and this is part of the metric overload, which is why it's a good idea to separate what's important and what's not. If you're using synthetic vendors and synthetic measurements, that tool probably has a way of gathering this information. If you're using RUM, fortunately, we have something called resource timing. How many people have heard about resource timing before? Great. Resource timing is relatively recent. It is a browser API that allows you to look at the performance components of every object that the browser fetched. And those are, if you look, this is from the spec, those are essentially all the components that I talked about. And you can actually gather these and report on them for your actual content being fetched. What's been happening recently for vendors that are doing any sort of testing in the browser is there's a movement towards just using resource timings because browsers support it now. It used to be that vendors had to essentially devise their own measurement. They start a clock, they stop a clock, and they report that time to you, which was not always accurate. This is now being kept in the browser, reported to you through APIs that you can access through JavaScript, and that's awesome. Just so you know, here are the browsers that are currently supporting resource timing. I don't know why Safari's behind. Hopefully they'll catch up. But most modern browsers these days are supporting resource timing. So resource timing is an area that I would definitely suggest some investment of time for you to look into. And if you are devising any sort of test or measurement at all that has to do with objects, definitely look into resource timing. You can open your console in your browser, type in window.performance.get entries, and you can actually see everything. You do need to, just a note of caution, you should look at the spec because there's probably lots of other notes of caution. But one note of caution, to get every single metric, you need a header on the object that allows the JavaScript to actually collect that from the objects in the page, especially if they're not on the root domain. Okay, I'm gonna pause here for a second and get into a slightly murky area. Now, part of the metric overload is considering too many things. And one of the areas that could really be a rat hole and can contribute to the too many things problem is considering either object metrics or page metrics. So object metrics I've actually talked about so far, which are things like time to first byte, TCP time, et cetera, et cetera. And page metrics are bigger things like time it took for the page to load, and time it took for the page to start rendering, and time it took for the page to do various things, execute JavaScript. To illustrate my point, where I'm headed with this, is I'm gonna show you my favorite performance tool ever. Web page test. How many people know web page test? If you don't know web page test, go use it. If you're already using it, you're smarter. Use it, and after you use it, figure out how awesome it is. Come talk to Pat right here and tell him what a great job he's done, because Pat is responsible for web page test. It is by far my favorite performance tool. What it does is you put a URL in. There are actual browsers that are being subjected to, as you'll see here, real-world conditions. There's an emulator that sort of emulates latency and bandwidth conditions. You can do a bunch of runs, and it reports a whole bunch of really good metrics, and it gives you a waterfall chart that shows you what your page looks like, and it judges you, which is what you expect from every good testing tool. These are great things, and everybody who is running any sort of web application should be familiar with what their web page test sort of fingerprint looks like. To illustrate the point, here's what I did. I took the Surge page, so the home page for this conference, and I decided to pretend like I was evaluating two different CDNs, and one was better than the other. Oh, that's cool. One, it's better than the fire alarm. I decided to pretend that one was better than the other to see what the impact of that is on page load time. So I did two tests. I did one test. Both tests had sort of real-world use conditions. So 15 megs down, it's like a real broadband connection, 15 megs down, 5 megs up, and I did 2 different latency profiles. One was 10 milliseconds. I just tested to origin. I didn't test with any actual CDNs. I picked a test node that's near where the origin is. I did one test with 10 milliseconds of injected latency, and I did one test with 25 milliseconds of injected latency. So essentially what I'm simulating is a CDN that is 10 milliseconds away from the user, and one that's 25 milliseconds away. One that's 150% worse. That's what I'm simulating, like a really bad situation. These are what the 2 waterfalls look like. Because you can't see any of that stuff, I'll zoom it in. Here's a little sort of window of those waterfalls, and you can see that my better CDN is doing its job. General download time for these assets that are supposedly coming from cache, it's a decent simulation, it's not perfect, but it's decent, is a lot less on the left with the 10 millisecond CDN. You'll see that they're generally under 20 milliseconds to fetch these objects, and they're generally in the 30s with the worst CDN, okay? So my CDN is doing its work, and if I was using these sorts of, each of these objects to sort of measure, I would know that one was doing kind of better than the other. Now, how did the pages compare? So I took 3 metrics from the 3 probably most important metrics and compared those. Now, what are the metrics I chose? I chose onload time, which is the sort of document complete time, the onload time in the browser. I took the start render time, which is when something starts showing up on the page, which a lot of people think is also important. And then I took speed index, which is actually a web page test metric that Pat came up with, which is an indication of page completeness, visual page completeness over time. The lower number is better. Now what's really interesting is, and I ran 9 tests of each, which is the most you can run with web page tests in the public world. If you deploy your own private ones, you can do lots more. What's really interesting to me is if I just looked at these metrics, I would actually think that the CDN that was 150% less performant was better for my pages. And that is a weird thing to see, because that CDN performs better for speed index, it performs better for start render, and it's behind in on load time, but not by that much. That is really weird. That's anti-intuitive. That's a weird thing to see. So if you ask yourself what the hell is going on, what's happening is we assume that all things are equal. And what happens when a page renders is actually a lot more than fetching those objects. Lots of things go into how long it takes for a page to render. Probably the biggest performance impact is the use of third parties. And sometimes between 2 successive tests, you're using different sets of third parties, because one call to an ad server may generate dozens of other calls to different ad servers for every different page load time. And this is a huge problem. And I was in an industry that did this. I used to live in these waterfall charts. And this was a huge mess to sort of get a handle on. So that's what's happening. JavaScript is executing on the page. There's layout issues. There's lots of things that go into the page loading. Because of this, there's a lot of variance. So what ends up happening is you could draw inaccurate conclusions by just doing a couple of tests like this and then deciding to go with the results. I have lots of people come to me with waterfall charts that say, you are not performing as the way I would feel like you should be performing. And the moment we go through them, we immediately recognize 5 different performance problems that have nothing to do with the CDN. So this is just one of those areas that could really be a rat hole and cause lots of confusions and headaches. And that's an area that you should probably be careful about. With regards to third parties, the search site isn't even that bad. There's only 9 domains, and less than 20% of the objects are coming from the third-party domains. According to the HTTP archive, which is the graph on the right, the average number of domains on a page is 17, which is a lot. So you can imagine how sort of varied this could be if your site, only 2 of the domains, 3 of the domains that come from the CDN, have 15 or 16 other domains that are responsible for the rendering of that page, but they have nothing to do with the CDN that you're trying to measure. I want to be clear about something. By no means am I saying you should not be using tools like web page test. You should absolutely use tools like web page test. You should always know what the performance of your applications, what what the performance of your application is, because that is what your users are experiencing. That should absolutely be something you're doing. You should do it all the time. You should continuously do it. You should use all the tools available to you to know what your application performance is. But you need to be very, very careful when you use metrics like that to indicate how well a CDN is doing for you. The caveat to that is that if you're using RUM to measure page performance, and you had lots and lots of data, hopefully that sort of normalizes the variance a little bit and can be a little bit more meaningful. But if you're doing 9 runs on web page test, or you're doing 15 runs with a synthetic tool that's doing something similar, that is gonna end up misleading you. It's weird to say this because I'm a performance guy, and I love knowing the performance of applications, but I've seen so many times diversions and cycles being spent misdiagnosing the problem, misdiagnosing the performance of a CDN because people have just stuck to whole page measurements and have sort of lost track of what the CDN is sort of providing for them. So that's weird for me to say, but I really thought that that was an important thing to bring up because I've seen it happen so many times, it would just be, seemed like it was a lesson worth sharing. Now, we've talked about ways to measure. We've talked about metrics. Let's talk about what to measure. So let's say we're ready to test. What the hell do we test? What's the thing that we test? So the most common way people do this is they pick a normal object, so some object like on their homepage. They set up some sort of test, usually a synthetic testing of some sort, from lots of locations around the globe, and they say test every 20 minutes and go. I'll come back in 5 days and look at how CDNs performed. And again, this happens a lot during the evaluation process. So it's like, you know, I have 5 CDNs, I'll compare these 5 CDNs, here's an object on my homepage, go test it. And you pick some metrics that you think are important, and you compare those, and you make a list, and you're like, okay, great, I know exactly what's going on. The truth is that this is all application dependent, and depending on what you're planning on using the CDN for, what you test is gonna change. So I thought the best way to cover that is just going through a couple of examples. Let's say you have a web application, and you want to measure things with a web application. Well, first of all, the ratio of objects that you're using the CDN for to send back to you from the cache versus objects that you'll be fetching from the origin through the CDN should kind of be an indication to you of what type of object you should be checking. If your HTML, which is the first object on the page, again, we're talking about web applications, is going through the CDN and is coming from the origin, you have to make sure that that is included in the set of assets that you test, because that is an important object that's being downloaded that's blocking for your pages. And a lot of key metrics for that page are dependent on how well that HTML is delivered. So that should be an object, a thing that you end up measuring. For your sites and your applications, you should probably have a graph like this. Now, I grabbed this from the HTTP archive, and it's a sort of distribution of size for the different types of objects that web applications will see. As you'll see, images, JavaScript, and CSS are generally smaller than HTML. HTML is sort of larger. And the median for a lot of these things is, I don't know, I would say the 50th percentile of the static assets is in the maybe 10K or less category, area. And for HTML, it's probably a little bit bigger. So if I was to use this as the distribution for my application, I would probably say that small objects are good enough for me to test because most of my content is sitting under 1500K. Who can tell me why 1500K is an important metric? Sorry, 1500 bytes. Yeah, 15K is an important metric. Good, one person. I'll talk about this in a second. You get a star. Okay, I'll talk about 1500 in a second, 15,000 in a second because that's an interesting one. Now, on any page, let's think about what components we care about. On any page, you're probably going to do a DNS lookup, maybe once, maybe twice for the objects, the domains on that page. If it's not in your cache already, you're going to set up 6 TCP connections per domain. That's what browsers do. And then you're going to fetch lots and lots of objects. So this is the reason that for web applications, probably time to first byte is going to be your most important metric. Maybe time to last byte minus time to first byte, so download time, if you have large objects, like maybe you have a big hero image on your homepage and you kind of That's sort of vital to how quickly your page loads. Maybe you want to measure something like that. You should have a good idea of what your DNS and TCP and TLS times are. But if you were going to focus on one metric, I would sort of sway you towards time to first byte and maybe time to last byte. You should know everything. You should have an idea of what's happening with everything else, but that's probably the area to focus on. Now, remember that when you're testing static objects, you're only testing what's happening between your client and a node that's supposedly close to it. So it's good enough to probably pick a couple of representative assets and look at time to first byte and maybe time to last byte. And please do everyone a favor, including yourself, and make sure that the object actually comes from the cache. This is a huge problem. Lots of people test things with incorrect configurations, and they think they know how the CDN is doing, and the object's actually not in the cache that they're testing. So every CDN usually has a header that tells you if the object came from cache. If they don't, you have to add a request header. That's a debug header that'll tell you. CDNs usually have this. Ask your CDN vendor to show you this header so you can make sure that what you're testing is what you think you're testing. That's an object coming from cache. If the object is not coming from cache, it's going all the way to origin. And remember, it may be going to the origin directly, or it may actually be going to the origin through another CDN node with a big middle mile optimization. If you're doing tests like this, make sure you pick a sample HTML, an object that's sort of representative of your HTML sizes. Look at TTFB because that's indicative of sort of how well we get the first byte back from origin. That's going to be indicative of routing algorithms and such. And time to last byte is actually core here because it tells you how well the CDN is delivering. Let's do a quick second example, like of a software download. Let's say your application software download. This is a little bit different because you probably have larger files. You probably have a download domain that you just fetch things from, like let's say some sort of installation file. So for this, I would pick an object that's representative of your EXEs, and maybe one that's not so representative, and I'm going to talk about why that's important in a few minutes. And then let's look at some core metrics. The ratio of TCP to HTTP fetches in applications like this is probably closer to 1-to-1. So maybe in situations like this, you kind of care a little bit about TCP time. But if it's a really large download, you probably care more about how long it takes to get the entire object there. So those are the metrics you would sort of look at. I would probably, in these situations, look at end-to-end time from beginning to end. But if you're going to focus on one metric, I would focus on time to last byte minus time to first byte. When it comes to this sort of measurement, there is a note of caution. When you're thinking about measuring bandwidth or download times for larger objects, always take into account where in the lifetime of a TCP connection you expect this download to happen. The reason for that is TCP connections behave differently in the beginning of the connection versus later in the connection. The amount of bytes that TCP is allowed to put on the wire over the lifetime of a connection kind of looks like this. Now, I did this by freehand, and afterwards I realized that this is actually what I want it to look like. That's not what it looks like. It looks like this. This is cubic. This is the default congestion avoidance algorithm that comes with Linux. And that's kind of what it looks like. And the reason 15,000 bytes was important is because the init CWIN, the first set of bytes, the first chunk of bytes that a server is allowed to put on the wire is by default 10 in Linux. And MTU for IP packets is 1,500 bytes. So we're generally around 15,000 bytes in the first sort of splurt that the server of bytes that the server puts on the wire. And that's why 15,000 was kind of a big deal, because usually with servers these days, the first chunk of data that comes to you is about 15,000 bytes. That's what you were thinking, right? Exactly. Okay, so when it comes to download time, know where it is in the TCP lifetime of a connection. In the beginning of the connection is a function of init CWIN, which sometimes is tunable based on the CDN you talk to. And if it's later in the connection, it's a function of congestion avoidance algorithms, and it's a whole different thing. Large files will probably experience both, but smaller files, things that are in the probably less than 100K area, are basically just going through the slow start of TCP and are kind of susceptible to RTT, and that's kind of about it. Now, at this point, I'm going to talk about cache hit ratios. Cache hit ratios are one of those things that we look at very heavily when we look at CDN performance. And they're actually not what we think they are. So traditionally, cache hit ratios have been cache hit ratios have been calculated as 1 minus the number of requests to origin over total requests. So if you have a CDN that looks like this, what you do is you have 100 requests that go into the CDN, and one of them squirts out the back to origin. You're welcome for that visual. To origin, we say that the cache hit ratio of the CDN is 99%, right? Because only one went to origin. Great, nice job, 99%, you're great. Let's look at what happens. What actually happens is your client is talking to a cache. Now, you open a TCP connection, great, that's usually 1 round trip time. Then you do an HTTP fetch, right? Now, if the object is being served from the memory of that cache, that has an entirely different performance profile, that if that object is being served from disk, that has an entirely different performance profile if that disk is spinning or an SSD, entirely different performance profile if that object is coming from deeper in the network. And traditionally, this has happened with really, really popular things being really close to the edge and less popular things, colder things, being closer to the middle, because CDNs have sometimes been built hierarchically. However, we call this entire thing a cache hit. Always, we call this a cache hit. Yet we see that for performance, this is not necessarily indicative of how well our users are experiencing things, because they may come from not necessarily close to the users. So when this has been the traditional calculation of cache hit ratio, maybe it's better to do something like this, which says the cache hit ratio that I actually care about for performance is the ratio of hits to total requests, which is actually hits plus misses, that are coming from the edge. In fact, they're actually both meaningful, except that the old one is kind of meaningful for the offload that I'm getting, what my origin is no longer seeing, which is also a thing I use CDNs for. And this one that I'm proposing is kind of a better one for performance. What's interesting here is what happens when you measure this and how it relates to long tail content. So long tail content is content that is cacheable when we fetch it infrequently, right? So I did this test. This is with a synthetic test. This is over a month. I'm going to show you data over a month. And I was actually very surprised by the results, and it's really interesting. I took 3 objects, a popular one that was being fetched once an hour, and one that was being fetched once every 6 hours. So a short tail, a medium tail, and a long tail. I know people say short tail and long tail. I don't know if medium tail is the term, but let's call it that. And there's lots of measurements that go into this. I'm sure what the data I'm going to show you is coming from a lot of measurements. Now, if you look at TCP time, each of them behave essentially the same. And the reason for that is because you're talking to a cache, and the TCP time is a function of network round trip time, and that's sort of expected. But look at what happens when it comes to time to first byte. The profile is completely different. And if every one of your requests is experiencing time to first byte when it's being fetched from the network, isn't it interesting to see that objects that are colder are behaving, and still cacheable, need to be cached from the CDN. You put a year-long expiry on that object, is performing very differently than objects that are hot and are cached sort of with higher frequency. And isn't this better? Now, before you jump down my throat, none of those two are Fastly. These are 2 different vendors. We may look like one of these more than the other, but that's beside the point. Neither of those 2 is Fastly, and that's my point. My point is that you should, when you pick objects to measure, you should think about how often that object is going to be cached and where it would sit in a cache. Is it going to be a hot object, or is it going to be a cold object? What would surprise you is sometimes testing an object. Let's say you pick a test asset that's not even on any of your pages. And you say, well, this is not on pages. It's not being fetched by users. That's going to be a good thing to test. Sometimes the testing itself will make an object hot. So that's a thing to sort of keep in mind. It's not easy to test things like this. I sort of had to get really creative to test this, but it's doable, and it's probably something you want to know about the performance of your CDN. Now, I went through 50 minutes and talked about why all this stuff is really important, and hopefully shared some experiences with you. I'm going to play devil's advocate for 2 minutes and say, does this all actually matter? And I'm going to caveat it with, yes, it does, but there are certain things, there's a certain big picture that we can't lose sight of. This is, as of 3 days ago, the Codexis top 20 rankings of a whole bunch of CDNs. I blacked them out because it actually doesn't matter who the CDNs are. This is the rankings. And you can see this. This is on their website. You can just go look at it. And you'll notice that the difference between first place and 16th place is 8 milliseconds. if you look at the medians, which is the middle column. Yet, if I was to look at the 95th percentile, I would notice that there's different CDNs that sort of rise to the top. And the 95th percentile kind of tells me how consistent a CDN is. So maybe it's not always a good idea to look at the medians and start making these lists. And I'm not saying make a list and sort this table based on the 95th percentile. What I'm saying is always have the bigger picture in mind. What's the bigger picture? It's not just the point of testing and the point of doing these comparison tests, especially when you're evaluating, isn't just to come up with a list where you have one number that's slightly better than the second number. It's lots of other things. You have to take care of, you have to understand that your application is a beast of its own, and what you're testing and how you're looking at your application and what goes into the performance of your application, the piece of the CDN piece is only one small piece of it. Don't lock in on a metric. It's really easy. I see this all the time. People that say, I'm gonna pick one metric, I'm gonna make a list, I'm gonna pick the guy on top, because that's really all that matters. I know intuitively that's an easy thing to do, but it can actually end up in the wrong decision. True performance isn't always easy to measure. Let's not forget our long tail performance, right? This is a function of how well a CDN stores objects and how well it can actually store things at the edge versus other places in the network. That's an important thing. And if you're not testing the right thing, or if you're not keeping these sorts of things in mind, you may not be able to, you may lose sight of that. Let's not forget cache hit ratios. Let's not forget how cache hit ratios represent our performance. Let's not forget about footprint. Is the footprint that you're testing the same footprint that you're going to be getting when you actually sign up with a service? Or does the service have cache nodes in the countries and places that you care about? Is their HTTP footprint different than their TLS footprint? And sometimes this is the case. So if TLS is important to you, make sure you have TLS in some of your testing models. What if the CDN allowed you to cache something that you couldn't cache before? All things are not equal. What if all of a sudden you put things on the edge that you couldn't put on the edge before? You didn't think you could put on the edge. This has happened. Customers come to us all the time testing with the assumption that they can cache something, and we show them that they can cache it. I'm sure this is true with any CDN, and that changes the picture. Always keep sight of things like that. Understand that these are things that go into the overall performance of your CDN experience. What if the CDN was capable of serving stale content when necessary? If your origin went down, or during revalidations, things like this. What if sometimes you have some tolerance to serving stale content? That certainly helps performance, and a lot of the metrics and the techniques that I talked about don't necessarily cover that, but it's sort of a feature that you kind of want to look for in a CDN. My key takeaways for you, if you learn nothing from this, if the last hour has been terribly boring, if you're going to take one thing away, is always understand that everything that you're testing is application dependent. So make sure you evaluate your application and do your testing according to your application's needs. Do not get locked into a single metric. It's really easy to do because we like lists, we like making lists, we like ranking things. It's not necessarily always that simple. Know your application, know where your application bottlenecks are, which means always use something like web page test or use whole page RUM to know the performance of your application. And always keep track of sort of the bigger picture. Lots of things that I talked about today are things that I myself do all the time. Lots of our customers, lots of people out there do it. But at the entire time, the lens we should be looking at everything through is the lens of our application to make sure we keep track of the bigger picture. I talked really fast for like 53 minutes, right? I'm almost done. Let me ask you this, was that helpful? This is the first time I've done this talk. Was that actually interesting, or was that really boring? It was interesting? Okay, thank you. Thank you, the 6 people. I think I have some time for questions, and if we run out of time, you got to kick me out, Brian, it's okay. I'm just going to be out there by the booth pretty much for the next 2 days, so you can come see me at any time. Any questions you guys want to ask while we're out in here still? Anybody? Yes? Okay. That it's actually being served from the cache? It's being pulled. So the question is, there's lots of fresh content that constantly needs to get pushed or get pulled from the CDN. And the challenge is to know that that object is actually on the CDN, because you may think it is and it isn't necessarily there. So I'll give you a really short answer, but it could be I may not cover everything, so come talk to me afterwards. We'll talk about your specific situation. The best way I've found for doing things like this is to use HTTP headers. And usually CDNs, like the header that I showed, that's the header we have, and actually a couple of other CDNs have the same one, but other CDNs have their own. There's usually a header that says this thing is coming from the cache or not. And that is a good indication of knowing if something is where you think it should be. And some CDNs will actually give you tiers of it. So they'll say that this came not from the edge that you connected to, this came from deeper in the network. Or this was a multi-cache lookup. You may get headers like that too. Sometimes you need to put a debug header in to invoke the CDN to do that, but those are generally available. This is the really easy answer to your question. There's probably more nuances, so come talk to me afterwards. We'll sort of walk through it. But I would say the best way, the way that we see used the most is just to use headers to make sure things are coming from where we think they're coming from. Anything else? Yeah.
What's an example of something that was previously uncacheable that made cacheable?
That is a great question. The question is, what is an example of something that was previously uncacheable that is now cacheable? I'll give you a customer example. We had a customer who was serving a piece of JavaScript. And that JavaScript was user tunable. Every user had a different JavaScript. And at any time, they may log into the application and tune their settings, and that JavaScript could change. Because of this, they had the tiniest TTL on that object. Actually, I think it may have gone stale right away. And what they were testing is validation to origin. Like they were testing, I want it on the CDN, but I never want you to serve it without validating to origin. This is a cached object, but it's not really, really cached. One way to deal with things like this is if you could get that object off of the CDN as quickly as you got it on the CDN, the thing that you thought was not cacheable is all of a sudden cacheable. Because anytime that customer goes and tweaks the JavaScript settings, you can actually send like an API call to the CDN that takes it off the CDN. That is one example of actually a huge use case. Lots of people don't cache HTML, but they can if they knew that they could take it off of the CDN as quickly as they put it on the CDN. And CDNs generally have been bad at getting things off the CDN and really good at putting things on the CDN. But if you find a CDN, maybe one here outside in red, that can get things off the CDN as quickly as it could put things on the CDN, then all of a sudden things that weren't cacheable become cacheable, and that changes the game, which is what my point was. Does that make sense? Okay, great. Anybody else? Brian, just shut me down when I'm done. Thank you, guys. I'm here all day if you have any more questions. Thank you.